Hi everyone and welcome. I'm Gavin Lon. Before we look at 10 reasons why Blazor on .NET 8 is a game changer, let's understand Blazor before .NET 8. In previous versions of .NET 8, for example .NET 7, which is currently the latest stable release of .NET, there were two available technologies that can be chosen for how the HTML for Razor components is created and rendered and updated in the user's browser. These options are Blazor WebAssembly and Blazor Server. Very basically, with Blazor WebAssembly, all of the code logic for the relevant Blazor application, as well as the runtime, are downloaded to the browser. So the code logic runs on the user's browser. So the C# code is run within the user's browser, which is made possible through the WebAssembly technology. When changes to a web page's content are made through user interactions with the web page, only the changes are updated within the DOM. So the entire page is not refreshed every time a page needs to change. This makes web page responsiveness extremely fast and gives the user a great user experience, UX. When the Blazor Server technology is used, the same SPA effect, if you like, is achieved, where the same kind of SPA responsiveness is experienced by the user. So, only the necessary change is updated in a web page as a result of the user interacting with the web page, and the entire web page does not need to be refreshed, which could result in the user staring at a blank page for a relatively long period of time before the desired rendered content appears within the user's browser. So, with both the Blazor WebAssembly technology and the Blazor Server technology, the SPA responsiveness effect, if you like, is experienced by the user, where only the changes through user interactions with the relevant web page are updated within the user's browser, resulting in a smooth, responsive UX. However, with Blazor Server applications, the code runs on the server and not on the client, as is the case with Blazor WebAssembly applications. So for example, when a change to a web page's content is made through a user interacting with the relevant page, code logic is run on the server, the relevant change that needs to occur within the browser is calculated on the server and subsequently sent to the browser via a Signal R connection. So a WebSocket connection between the client and server is maintained for Blazor Server applications. This persistent connection between the client and server can be described as a circuit. This circuit is not required in Blazor WebAssembly applications because the C# code runs on the WebAssembly technology within the browser. Note that in Blazor WebAssembly applications, the application's data is typically stored on the server, but is passed to the client when needed via a typical HTTP request-response model, and does not use a Signal R connection, as is the case with Blazor Server applications. So this is how Blazor worked in previous versions of .NET. The SPA application's responsiveness was made possible through the WebAssembly technology or through a persistent WebSocket connection, a Signal R connection. Note that the functionality we have just discussed, Blazor WebAssembly and Blazor Server, still works in much the same way on .NET 8, but new features and enhancements have been made. To support the channel, please hit the like button and please consider subscribing. Please also ring the bell so that you'll be notified of future content. Please feel free to share this content with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do this through my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. So, here are my top 10 reasons why I think Blazor on .NET 8 is a game changer. And they are in no particular order. Number 1, server-side rendering, SSR. With .NET 8, server-side rendering has been introduced to Blazor applications. So, how does this technology differ from Blazor Server and Blazor WebAssembly? With SSR, the code does not need to run inside the user's browser, like in a WebAssembly Blazor application. So the relevant files containing the relevant code logic and the necessary runtime does not need to be downloaded into the user's browser. A Signal R connection or a circuit does not need to be maintained, like is the case with Blazor Server applications. With SSR, A typical HTTP request response model is used, where a HTTP request is made by the browser to the server, the relevant web page is rendered in its entirety on the server, and then streamed to the user's browser via a HTTP response. Server-side rendering is currently used for both MVC and Razor Pages apps, but is new to Blazor apps with the release of .NET 8. So, what are the advantages of server-side rendering? Fast load times, which includes the initial loading of your website or web application, as well as faster page transitions within your website or web application. SSR is great for boosting your SEO, search engine optimization, because it indexes your pages before they are loaded in the browser. With server-side rendering, content is theoretically easier to crawl and be indexed. Indexing SSR sites is much easier for search engines than client-side rendered sites. The content is rendered before the page is loaded, so JavaScript does not need to be run to read and index the relevant pages. More accurate user metrics. Unlike CSR, client-side rendering, SSR will inform the server as users move between your web pages. Evaluating how your users navigate your site and interact with your content will help you continually improve the user interface, UI, and user experience, UX. SSR is ideal for static web pages, as it is faster to pre-render a static page on the server before sending it to the client. SSR is excellent for social media optimization. This means previews of your website can be easily presented with the relevant page title, description, and image wherever your web page's content is shared on social media platforms. So with SSR, the relevant web page is stateless, and a typical HTTP request response model is used to handle the requests between the client and the server. With WebAssembly and Blazor server, state is maintained. In the case of WebAssembly, the state is maintained on the client, and with Blazor server, the state is maintained between client and server through a circuit made possible through a SignalR connection maintained between the client and the server. Number 2, streaming rendering. So you might be thinking, okay, great. We've got all these advantages with server-side rendering. But what happens if the page that is requested involves a long-running operation, for example, a data retrieval operation, that causes the page to be relatively slow to render? This could result in the user staring at a blank screen for a frustratingly long period of time. In this case, doesn't this defeat the purpose of creating a SPA application in the first place, where you'd typically use a SPA technology to create a fast and smooth user experience? Well, this is where streaming rendering can be so effective in maintaining the SPA effect, if you like, where the static part of the page is loaded, for example, the header, the hero section, and the footer, almost immediately after the relevant page is accessed. And then the dynamic part of the page, hindered by the long-running data retrieval operation, can be streamed later to the user's browser once it has been appropriately rendered on the server. Note that a WebSocket connection does not need to be created for streaming rendering to occur, so a SignalR connection does not need to be maintained between client and server. The dynamic part of the web page can be sent in the same HTTP response stream, but at a later time. So, for example, from a user's perspective, the header, hero section, and footer would appear in the user's browser almost immediately after the relevant web page is accessed, and perhaps a loading indicator is displayed to the user while the relevant dynamic content is being rendered. Once the relevant dynamic content is rendered, it is sent via the HTTP response to the browser and subsequently replaces the loading indicator in the user's browser. So with server-side rendering and streaming rendering, part of the page can be loaded asynchronously in the user's browser via a HTTP response. This means the advantages of server-side rendering can be leveraged in Blazor applications, and the responsive nature inherent in SPA applications is still maintained. Number 3, enhanced navigation and form handling. Blazor on .NET 8 comes with an enhanced navigation feature. This magic, if you like, is switched on through a reference to an enhanced version of the blazor.web.js JavaScript file, which is referenced from within your Blazor project's app.razor file. As discussed, there are many advantages to leveraging server-side rendering, but we don't want to, at the same time, cancel out the responsiveness features inherent in this SPA technology. Enhanced navigation means that content is still server-side rendered, but the result is when a navigation is performed, only what is needed is downloaded from the server to the browser. With enhanced navigation, a fetch request is made and only updates the DOM with the necessary changes. So any files and content that is already present in the browser does not need to be refreshed in the browser window when a navigation is performed from one web page to another. Blazor intercepts the request when a navigation is performed from one web page to another. Blazor intercepts the request and updates the DOM with only the parts of the web page that need to be changed. This results in a smooth, fast navigation effect. So benefits we have discussed regarding server-side rendering are leveraged, while at the same time the UX responsiveness you would expect when leveraging a SPA technology is maintained. Form handling is another benefit delivered in .NET 8 for Blazor applications, where, for example, if a user fills in a form whereby the user needed to scroll down the page to reach the relevant form, when the user submits the form with server-side rendering, this would typically result in a complete page refresh where the page would reload and the user would lose the user's scroll position within the page. So with enhanced form handling, only the parts of the web page that need to change as a result of the user submitting the form to the server are changed, and the scroll position on the web page experienced before the user pressed the submit button is maintained even after the form is submitted. This ultimately results in a smooth experience for the user. You can test the effect of enhanced navigation and form handling by commenting out the reference to the blazor.web.js file within the app.razor file, testing your application, and then commenting back in the blazor.web.js file and retesting the relevant functionality. Number 4, choose component rendering mode at runtime. So we've discussed server-side rendering and streaming rendering. This is great for initial page loads. We have also discussed enhanced navigation and form handling, which gives our application the advantages of server-side rendering while maintaining the responsiveness effect expected when using a SPA technology like Blazor. With .NET 8, we are also able to leverage the Blazor WebAssembly technology and the Blazor server technology within our Blazor applications running on .NET. We can in fact include server-side rendering, streaming rendering, Blazor WebAssembly components, and Blazor server components within one project within our .NET 8 Blazor applications. By applying an appropriate attribute at the top of a Razor page, we can, for example, explicitly choose that the relevant web page leverage the Blazor server technology, which means a signal R connection is created automatically to handle relevant client-server interactions. We could explicitly change the relevant attribute appropriately so that streaming rendering is used for a particular page, which means a signal R connection will not be used and a typical HTTP request response model is instead used. Note that it is not recommended that you always bind a particular page to a render mode. This should be done sparingly. It is recommended that such choices should be done through applying the render mode attribute to elements that denote the inclusion of the relevant Razor component as a child component within a parent Razor component. This will give you more flexibility regarding the context in which the relevant component is rendered. So, a component can be rendered, for example, as a WebAssembly component or a Blazor server component, and this choice can be implemented through the use of the render mode attribute included appropriately within the relevant element that denotes a Razor component. You can also choose the auto render mode for a component, which, for example, would mean that a component is initially loaded via signal R connection, which means it behaves initially like a Blazor server component. While the page is loading via a signal R connection, the runtime and relevant files containing the code logic could be downloaded in the background, so that subsequently this component can behave like a WebAssembly component. The advantage of this is you can leverage the faster initial load times inherent in the Blazor server technology, as well as the inherent faster responsiveness to user interactions inherent in the Blazor WebAssembly technology. So you can get the best of both worlds, if you like, through an appropriate implementation of the auto mode render mode. Number 5, QuickGrid. Also shipped with .NET 8 is the QuickGrid component. So a use case for the QuickGrid component is that you want a fast, lightweight component that can display your data in a grid. Perhaps you want to display your data across a number of pages. QuickGrid supports pagination. For information about what functionality is provided in the QuickGrid component, you can navigate to the QuickGrid demo site at this URL. You can see here we have pagination functionality. You can include and exclude the fields you want to display within your grid. Not only can you include text-based data, you are also able to include images within your grid. You can sort the rows by clicking on the relevant column headers. You can filter the data within the rows using text-based search criteria. You can customize the look and feel of the grid using CSS style sheets. So it's a basic grid that you can leverage for quickly displaying your data within a grid. You can also easily customize your grid, for example, by adding functionality for sorting the data, filtering the data, styling the grid using CSS, and include pagination. You can even leverage the virtualization functionality. Virtualization provides the appearance of continuous scrolling through an arbitrarily large dataset, while only needing to fetch and render the rows that are currently in the scroll viewport. This can provide excellent performance even when the data is vast. QuickGrid's virtualization feature is built on Blazor's built-in virtualized component, so it shares the same capabilities, requirements, and limitations. So QuickGrid provides you with basic grid functionality. For more complex functionality, QuickGrid might not be the component to use. And perhaps you could use a more sophisticated grid component, for example, the SyncFusion Data Grid component. For more information on how to use the SyncFusion Data Grid component, please navigate to this URL where I demonstrate how to use the SyncFusion Data Grid in the context of developing a sales management application using Blazor Server. Number 6, improved authentication. Prior to .NET 8, a third-party component, Duende Identity Server, was used for setting up authentication for SPA applications. For many SPA applications, a full OpenID Connect server solution is way more than is required to satisfy authentication concerns. Duende Identity Server is a great component, but may not be appropriate for all solutions. In .NET 8, Duende Identity Server has now been removed from the authentication-related templates. Duende provides templates for your applications if you do need a full OIDC solution. And in these scenarios, Microsoft recommends that you use their templates for this purpose. In .NET 8, Microsoft has introduced client-friendly endpoints for identity management. For example, where your applications can get bearer tokens or set up cookies and query the identity data stores for information about the users. The other authentication-related improvement that comes with .NET 8 is that prior to .NET 8, you were restricted to Razor Pages templates for implementing UIs for the integration of authentication functionality into your web applications. So, for example, if you want to include login and registration forms in your web applications, you would include the appropriate login and registration Razor Pages in your application. At the end of this video, where I demonstrate creating a sales management application using Blazor Server, I demonstrate integrating identity into the application where the relevant login and registration Razor Pages are included in the relevant project for authentication purposes. As discussed, in .NET 8, you can use the new client-friendly Web API endpoints to get bearer tokens or set up cookies and query the identity data stores for information about the users. With .NET 8, you are therefore not reliant on these Razor Pages templates for the integration of authentication into your web applications, so you won't be tied to the Razor Pages technology for this purpose, and can customize, for example, in your Blazor applications, your login and registration forms using Blazor. Not only is this great for Blazor SPA applications, you can also use these authentication-related Web API endpoints and customize your own authentication-related UIs using Angular or React in your Angular or React applications. Number 7, Razor Component Result. Integrate Razor components into other types of applications like MVC, Razor Pages, Angular, or React. New in .NET 8 is the ability to return a Razor component result, which you can return from, for example, a minimal API or an MVC controller action. So this means you can easily integrate Blazor components into, for example, existing MVC applications. So for example, instead of rendering an MVC view, you could choose to render a Blazor component instead. You can turn a Blazor component into a custom element and, for example, integrate your Razor components into Angular or React applications. Number 8, generate static HTML content with components. You can now render Razor components completely outside of the context of HTTP requests, so completely outside the ASP.NET environment. So your Razor component can be rendered directly as a string or stream, and therefore your Razor component can be used for templating HTML. So this is useful for scenarios where you just want to generate static HTML fragments that could be used, for example, for email generation. So this is just added flexibility that is included with the release of .NET 8. This functionality also lays the groundwork for static site generation in Blazor. So this will mean that if the site can be generated into HTML on the server, for example for a web page, the web page is already rendered, so of course this increases the speed of retrieval of the web page, and therefore results in a better UX. Static site generation will not be included in .NET 8, but will be available in future releases of .NET. Number 9, the introduction of sections into Blazor. In .NET 8, sections can be used within Blazor applications. For those of you familiar with MVC, you'll probably know how sections work. You can use a section in your web application so that, for example, the content in a certain part of a header component changes depending on the current web page displayed to the user. So if the user is currently navigated to, for example, a web page displaying a weather forecast for the week, a section in the header of the web page could display, for example, the high and low temperature for the current day. So the content in a defined section of the header changes according to the user's navigation context, if you like. So if, for example, the user is looking at a web page showing the latest news stories, perhaps the latest breaking news headline is displayed in the relevant section in the header of the web page, where the web content was displayed when the user was looking at the web page containing weather forecast data. So you can see how this could be a useful feature to use within your web applications. Number 10, Jiterpreter. Much faster WebAssembly components. Currently, your Blazor WebAssembly apps run on an interpreter-based runtime. Limited JIT support will be included for Blazor WebAssembly components in .NET 8. What this means is significant runtime speed improvements, including 20% faster UI rendering and 2x faster JSON serialization. So these were just 10 reasons why Blazor on .NET 8 is a game changer. So massive improvements and enhancements are shipped with .NET 8 that will have a massive impact on your future Blazor applications. This is very exciting indeed. I hope you have enjoyed this video. If you liked this video, please hit the like button and please consider subscribing. Please also ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do this through my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. I hope to see you soon. Thank you and take care.